Morning, everyone, and thank you for joining us today on this webinar. Today's webinar is on value addition using integrated approach to steel detailing. Mr. Sunil Shah would be presenting this to you. I'll just give a very brief on Holtec as to who we are. Um, Holtec was started in 1967, which is almost 60 years back. We are primarily focused on global cement industry, to which we offer a comprehensive end-to-end solution. We also offer services in highways, power, and engineering support services, or steel detailing, on which we also have our today's webinar. We have done some 4,800 assignments till date for some 1,000 clients across 100 countries. We are an ISO certified company, and we operate from three offices in India. We have one office in Sharjah, and we also have various site offices. I'll just show you how we are planned. If we see, we have executed various kind of projects across the world, from Australia to US to Middle East, also in Europe, and of course India being our biggest client base. We have done various kind of studies like due diligences, raw material studies, feasibility, strategy studies, performance enhancement, and of course we do project engineering, procurement, field services, etc. Basically for cement plant. We have engineered over 100 large size cement plants, both greenfield and brownfield. And steel detailing, on which our today's webinar is going to happen. In that, we have executed 500,000 tons of steel detailing projects. So this was a brief on Holtec. Now I'll hand it over to Mr. Sunil Shah, who will take you forward from there. Here, thank you.
Thank you, Salini, for the brief introduction. Hello, everyone. I am Sunil Shah from Holtec, and I'll be your host for today's session. Today, I'll walk you through the evolution of steel detailing workflows. You can see today's topic is value addition using integrated approach to steel detailing. So, you know how we can address the challenges of traditional methods and show you how modern solutions like 3D modeling, CAD integration, and material management systems are transforming the industry. So I'll also be sharing some practical insights on how we can leverage these tools to enhance collaboration, accuracy, and overall project outcomes. So I am looking forward to an engaging session with all of you, and I encourage you to ask questions at the end of the session. So let's get started. So today's agenda points are number one is typical flow of drawings and information. Second one is challenges with old ways, that is, working on a 2D. Then third one is a solved in a better way. Fourth one is integration with the other trades with BIM. And we have 5 project examples which will be showing it to you. Then fifth to ninth are these are the output files which comes out from the Tekla model, 3D model. From there our fabrication process starts. So let's start with a typical flow of drawings and information. So here you can see, this is a comparison between the old way and the better way. Legend shows arrows in different colors, how drawings and information is passing through various teams. The red color indicates queries on fabrication drawings raised by the fabricator or site team, and the green arrow indicates clarification on those queries. In the old way, you can see detailer is working in isolation. You can see detailer here working in isolation with the fabricator. And a better way is a Holtec way, where civil engineering team is integrated with the detailing with 3D options. So in a better way, integrated detailing team is working with Holtec civil engineers, that you can clearly visualize here. And you can also see, less number of red and green arrows. It means, information directly passing to the Holtec team as far as the questions on fabrication drawings are concerned. It means definitely there is a saving in the time, and also there is a saving on involvement of other people, which is very much not necessary, and which will save lot of time in projects. So coming to the next, we have a challenges. What are the challenges we have in old ways using a 2D CAD drawings? You can see the first challenge comes with the inconsistent quality of execution. 2D drawings do not actually provide an effective way to visualize complex designs, then leading to misunderstandings, misinterpretations, and inconsistent updates, resulting in the errors and rework. uh, and they normally use a normal detailing softwares, which does not guarantee a consistent quality. Second challenge which really affects the customer is a poor control of steel quantities. So, they prepare a quantity sheet without the real time tracking, and it's a manual data entry in the BOMs. Material may be ordered in excess or in insufficient quantities, leading to cost overrun and delays. So, problem with material consistency is a real problem nowadays, and which also cause higher wastage. So you can see wastage is a main criteria, and reconciliation and lot of other problems are involved here. The third challenge comes with extra time and efforts taken in coordination. You can see the changes and revisions also happen during the process of the engineering process, where detailing and engineering are involved, and it takes a long time for the outside detailer to communicate, which leads to project delays. And there is another challenge, that outside detailer may not understand the design inputs fully, which may lead to a big problem at later stage, and by that time project may get delayed and even may go for a cost run. So now I'm showing you what are the better ways while we are using 3D modeling softwares. The first thing is that you get highly improved quality of execution. So due to 3D modeling, highly quality fabrication erection drawings integrated with civil engineering processes are produced. 3D rendering gives stakeholders a real view of the project, and you can see we have also worked for so many customers in US and other advanced countries, and we are specialized using specialized softwares, which is an advantage in providing a highly improved quality drawings. Second benefit you have is precise control of steel quantities. See, accurate BOM along with the drawings and accurate advanced bill of material is a real challenge. From 3D, since you are connecting all the members, keeping in mind all the dimensions as per the input drawings, so which normally creates a very accurate ABM, and material ordering happens on right time, which leads to a very significant reduced wastage and cost. So this is a very important thing. 3D modeling guarantees precise control of steel quantities. Another third advantage you have is simple, efficient coordination. See, our policy always is first time right and consistent design and fabrication drawings from a single point of view contact. You saw in our earlier slides, uh, information what is arising from the fabricator is directly reaching to us. So it's a kind of a single point of contact. And we solve all the issues in house with our civil engineering team, and quality queries can be directly resolved by our team, integrated team. So consistency in design and fabrication drawings reduce structural conflicts during construction. So these are the three benefits in 3D modeling. Now we have a as it's a main topic is integration with other trades and BIM. So we'll be sharing with you, 5 examples while using 2D drawings into our 3 modeling system. We will show you how 2D civil drawing, is utilized, how 2D mechanical drawing is utilized. And third example is integration with RCC 3D model. This model normally comes from other parties, and where main structure is made up of RCC and steel. Then you have to coordinate lot of steel members with RCC. Insert plates are involved, anchor bolts are involved. So coordination of these with 3D RCC model from outside party really helps, and the final drawings which comes out gives real advantage, and it's a smooth flow of work and construction. So I'll be sharing all five these examples with you. So let us start with the first example: integration with civil 2D drawings. uh, this is a I'll explain to you. This is a 3D view of a model which is taken from the Tesla software. Here, different colors showing different kind of structures. So where I am running a pointer, these are the columns in yellow colors, gray colors, and green ones are RCC slabs. And you can see, easily identify the steel structure here. There are three sets over here. Two are on this side resting on a RCC building. You have a couple of two stairwells here running here, and a giant steel structure on other side. Here is another cable gallery inserting inside the RCC building. And you can also see, couple of platforms inside RCC building. So you can understand from the this 3D view itself, how much coordination is really required here. You have to take care of all the dimensions. You have to take care of all the information provided in civil drawings. So our, main task here is to how accurately we can utilize these 2D drawings. So when you are working with the only 2D environment, these things are not possible. Here, what we are taking advantage is we are inserting these 2D civil drawings here and finding the exact location of RCC beams, columns, and helping civil guys, civil team, where their insert place and anchor bolt should be located, so that there is no conflict between steel and RCC members at later stage. And project is executed and erection is done smoothly. Here is a floor plan of a same building, where you can see clearly, those who understand the AutoCAD file, clearly showing these in red color beams in sizes, their widths. There are a couple of openings here, some staircase indication here, some here. So likewise, in all the floors we insert these AutoCAD files. These really help us, number one, identifying where the RCC column is terminating. Like here, you can see our steel column is erecting from the on top of the RCC column. Here, the same thing I am trying to show you. This is the RCC column, and the plan I was showing you that it is starting from here. So likewise, you have proper coordination from the very beginning of the project, and it really reduces lot of to and fro with the parties, and it is coordination is done within the Holtec team. So in this project, the tonnage involved was around 800 tons, and currently the progress is going on smoothly. All project what we are showing you here are the current projects, or some may have been completed, erection has been done. So there are no issues coming in terms of conflict with insert plates, anchor bolts, and any conflict with RCC members, because everything is being taken care inside the model before the problem reaches to the site. So you saw advantage of 2D civil drawing being used in 3D Tekla while doing steel modeling. Similarly, other trade is we want to show you mechanical 2D drawing. How mechanical 2D drawings, where you have equipment, ducts, and everything, how we can utilize it, and we are using it. So this picture clearly shows you ducts passing through various floors. though due to clarity, we have hidden some of the other branches of this duct, and it is passing material from here and going down. So likewise, it is passing through here. You can see number of floors. So you can just check in green color. These are the column places where our Tekla model has to create a support for these ducts. So here, very clearly, with 100% precision, we can, do steel modeling of this support. See, on right side, it shows a Tekla model exactly showing a steel model. On other side, we have hidden that just to show you that these red colors are indicating that here, duct support supplier needs a supports. So coordination for such kind of structures becomes a Herculean task. There are so many things which comes out only at site, which leads to a lot of confusion and unnecessary stress to the team, and it creates a lot of problem. So what I want to show you here that we can even utilize, these equipment mechanical drawings where even insert plate location and support location to the exact elevation, it can be done so easily. So here, roughly tonnage wise, this project, this was around 200 tons, and it was done, very quickly. And I will tell you, whenever the changes comes out from the, another 2D drawing comes out from the supplier or mechanical department, we just simply replace this 2D CAD drawing and replace it with the latest one, and we immediately come to know if there is any, conflict happening, and we coordinate everything. So what we did here, we checked if the duct is passing through slab opening smoothly at every floor without any interference with the seal structure, and it was easy to place duct support easily at right location, which you can clearly see from the zoom view of the same structure. Here, duct is passing in elevation. You can see, those who understand it, it is a elevation showing a duct passing from, coming from slope material going down. Here are these are the floors where we have to detail supports. So these are two kind of blade girder supports, which were exactly placed at the right location. And this gave us an advantage without any, fear in the mind that there may be a conflict at site. So you can understand the real advantage we are getting, in inserting these. This is not really possible while we are doing it in 2D drawing. So another great example we have is integration with RCC 3D model. Whatever we discussed so far was, integration of 2D civil drawings. Then we discussed integration of 3D 2D mechanical drawings. Now here is a integration with RCC 3D model. You can see a giant structure made up of RCC. You can see lot of steel structure on top of RCC. Then you have something, coming out here. Then there are number of platforms inside these RCC buildings, which we have to, coordinate with steel model. The great thing what happened here that you know, this RCC model was shared with us. In earlier ones, it was 2D drawings. Here, RCC model, 3D model was shared with us, which was a great advantage for us. And uh, floor-wise insertion of AutoCAD was not necessary. So the total tonnage is here is around 600 tons. When you can see 1, 2, 3, 4, around 8, 10 floors, having a good heights, and where we have to fit the support the equipment. We have a steel structure which can be seen here. So I'll be sharing, some zoom detail of part wise of this whole structure. This is showing a full-fledged building in a larger view. So second one, we are trying to show you the top portion of this RCC building. You can see, circular openings in slab, which was there already there in the model. So keeping everything in mind, coordination was done. This steel structure was created right from here. You can see staircase, cladding, then roof trusses. And in skew pattern, you can see, this gallery material passing through here with platform. So many activity happening, and doing in it Tekla with ease is a real advantage. You can understand, doing a detailing in 2D for such kind of structure is how much risky it is. There may be a lot of material wastage, there may be a lot of delays, because here coordination in 2D is not happening like the way we are doing in 3D model. So similarly, same structure at middle height, you can clearly see a staircase passing through inside. Some RCC columns are terminating here, and one small platform with some, structure attaching with the giant RCC column. So you can clearly see the insert plate location. It was easily coordinated, and it was informed to RCC modeler that where he has to place the insert plates, and here where he has to place the anchor bolts. So coordination became very easy. You can see any conflict coming, arising at site is being resolved within the model here itself, within the Holtec office. You can understand, kind of a problem normally, during construction we can face, but here everything is running very smoothly. So another, same structure, another, some zoom area I am trying to show you here. Between two RCC floors, you have a hanging structure. So imagining this in 2D, becomes a very problematic. You have to cut the section in 2D, in all the direction. But I can visualize the whole structure between two RCC floors, how it is has to be erected, where insert place I have to place. So immediately, when we model this structure from using supplier drawings or AutoCAD drawings, we are easily able to visualize in 3D how this hang, where at what location this RCC steel column is starting, where they need to place the insert plate, whether there is an insert plate at this location or not in RCC. That way also, that integration between civil and uh, uh, steel detailing team is taken care. So you are seeing the, how, smoothly work can be done, and wall insert plates, connection, everything is being taken care. Any conflict between steel and RCC members, it will resolve within the 3D model. Another view here, what I want to explain you, floor to floor height is very huge, where some equipment processing is going on. You have a circular openings here, a lot of things happening here. One is platform here with handrails, supports. Then you have number of bracing. Here are handrails. One thing I want to highlight here is in this picture that you have a deep RCC beam, just above this platform. So it was very easy for us to, find out the headroom here, whether will be a problem after erection or not. So this way you can see how easily we could visualize and find and tell the engineering team that no, this RCC beam may create a headroom problem here. So you saw conflict between his RCC and steel beam was resolved within the 3D model. So this is the real advantage of inserting a RCC 3D model, and complex structures like this one, you know, can be executed very smoothly. Not much queries from site. If any query comes, we share these snapshots with the customer, so that they can better visualize it and uh, take the action if necessary at site. Now, another example I am going to show you in terms of complexity. Complexity means sometimes what happens if things are in a complementary ways. Like this one I'll show you is a very complex dome roof structure where you can clearly see belt conveyors passing through penthouse. Then you have RCC silo down there, then ring beam, and you have to detail every radial truss with sway trusses. Then you have a radial purlins, then you have a ring beam up here. So how complex it is. So we have seen in the past when these things are done detailed in 2D CAD. We saw that detailing team sometimes misses the actual dimensions because we cannot visualize the things in 3D. So 3D visualization, accurate connection of roof purlins, top and bottom beams, braces becomes possible. And again, insert plate, anchor bolt on top of RCC ring beam, supporting radial trusses. These were coordinated very smoothly. But yes, we had to, made a dummy model of RCC silo down there just to get a, real feel while we are working in the 3D model. So these are some of the zoom pictures. Here you can see a ring beam of here, and these radial trusses are connecting with rail beam. Here is a sway truss. So this sway truss is a Herculean task to detail in 2D. And also, here you can see purlins are in slope in one direction on their own slope. Again, they have to connect in with other slope with these trusses. So these small connection which we are looking so small, but in reality they are so complex to detail in 2D that most of the time it leads to a problem at site. So these kind of a things, complex structure can be easily visualized. We can easily accurate do modeling, because modeling of radial trusses is not a easy thing, and visualize is there. Then again, insert plate anchor bolt on top of ring beam, and you know support radial trusses were coordinated. So this is like a 400-ton project. This was only this part was there, and we generated the fabrication drawing very smoothly. I'll show you in next picture. This is a radial truss. We have hidden lot of purlins for a clarity. This is a ring beam where truss is connecting. Again, purlins are resting here. Then we have a embed connection and anchor bolt right here on a RCC ring beam. So you can clearly visualize how 3D modeling is, benefiting everyone. You have a saving in material, you have saving in time, you have a less people are involved here. So likewise, there are so many advantages which we want to highlight. And we are currently doing it. We are doing it successfully, and we will keep on doing it, and we will, will utilize these advanced tools in future also. Now, just a difference from earlier samples, examples, here is a BIM project which we are currently doing with our US customer. See, BIM in the sense that, first I'll tell you, this is a, part view of a steel model with MEP model at initial stage of the project. You can see in white colors, these are the mechanical, electrical, plumbing model which customers shared with us. That was used in a Revit platform which we inserted in our Tekla platform, and the green ones are steel structure which we started generating and coordinating with these forms. So initially we got a Revit model, then we shared our own Tekla structure just to start the modeling. In this area, I'll show you in the next picture, these pipes are hitting the staircase. It means this pipe modeler did not follow the dimensions. See, had it been done in 2D, there would have been disaster at site, pipe hitting these stairs. So these are the real advantage in BIM. And in next picture, I'll show you, this is the pipe, which is hitting the stair in the beginning of the project. So what we normally do, we share our Tekla model in the form of IFC. Customer shares in the form of, sometimes ISC, sometimes they then directly send the Revit model. They also send us the Navisworks model, which we convert to IFC, then we insert it. So normally we insert IFC files inside the model for the BIM, and all coordination, is taken care by the customer, by the BIM manager at site. So this is the normal way of working with the US customer nowadays, and it is a normal practice. So here you can see, from earlier pictures that model has grown so much, where we have started shown ladders, handrails, all equipment pipes without placings, everything in well in place, with handrail here, stairs passing, except these pipes, which were supposed to rest on these Tekla structure supports. So these pipes had to be shifted here, which we will show you in next picture. This is again, middle stage project view. You have seen that pipes which were hitting here has been disappeared and they have been shifted here in right place. And now you can see some more things here. This green one is our Tekla structure, and here handrails in gray color. Here these are tanks done in Revit model. Then you have a cable tray in yellow color, exact location. Then you have a control panels here. Then pipe is passing through existing structure. So you can see how smoothly things are growing. Model is growing, and we are coordinating it. In next picture, what I am trying to show you, that I have hidden other parties models. I want to show you how much this model has grown now. All pipe structures, all platforms, handrail, these are our part of scope. And we can clearly see after checking conflict with other vendors like MEP modelers and piping modelers. When there is no issue, we start creating a drawings from here, this model, and we start releasing sequence wise to our customer. One thing in a second picture I would like to highlight you, to avoid any problem at the site, customers shared with us a point cloud model, which is shown here in gray. So this building was within the existing building, where the main challenge for the customer was how to transfer the site information to a detailer or fabricator. So our fabricator simply gave us three model, one Revit model showing these pipes, then cable tray within the Revit model. Then they shared with us piping model. This was shared in Navis Works. Then they again shared a point cloud model, which we inserted, and we found that all floors, existing floors and walls can be seen clearly here. So what we did, we coordinated our column base plate with the site model, and it is being, you can imagine, it is being taken care right within the model. So any side issue, being resolved within the model. So that way, you can understand how advanced this, detailing has gone, and everything being done virtually within the model and being solved. So that, later state project do not run, overrun the cost, and at the same time, other, costs getting effect for the other agencies. Here is another model I am trying to show. This is a picture taken from the, maybe a drone camera in that same model. This is a monorail, which we can clearly coordinate that there is a sufficient height between cable tray and monorail. And again, similar cable tray passing through. And these pipes, passing through and going on other side of the building. So finally, we were able to coordinate everything with all the stakeholders, and our Tekla steel structure was right in place and well coordinated. Now you can see a full view of this project. For the clarity, I have hidden point cloud existing model so that you can clearly visualize. You can see all tanks and mechanical equipment in place, all cable trays well in place. And this structure is on other side of the building, which was not visible in earlier one. But here, for the clarity, you can see pipes running. And these are the small brackets which we had to rest on existing structure. So you can clearly visualize how smoothly things are going here, and all the stakeholders, all the team members are taking the advantage of it. So this is a normal practice there in US, and we are trying to bring this here in India in most of our projects, and we are trying to convey our customers, though there may be some difficulties in initial stage, but this is what is going to happen in future. And you can understand from here, we are almost future ready. In fact, we are ready. Now we will talk about, so far we talked about the modeling and integration of 2D drawings, then BIM models. Now here I'll show you what are the outputs which comes out from the 3D model. So this is the first, material list. We call it an advanced material list. It comes in the form of an Excel sheet, or it directly comes from the Tekla without any title. So with a foreign client, they want it directly, but we have a, for our customers, we have this advanced bill of material with in Excel form. So here you can see the advantage when your main steel structure is right in place. We immediately generate this advanced bill of material, you know, and we share it with the customer so that they can book the material well in advance within the mill, with the mill. So what happens in US, prices of material keeps on changing. So the at the very beginning when project start, the main target of the fabricator is to book the material to as the earliest stage so that they can freeze the price and pick the material. Now you can ask that if some changes are happening, what will happen? Normally, if any changes takes place, this advanced bill of material automatically updates, and we share the same to the customer and we indicate where there are the changes. So this way they have the real advantage, and there is no manual adjustment here, and we ensure their accuracy of material ordering, reducing errors and delays. So there is a clear advantage here. And next output which comes from the 3D model is a fabrication drawing. So you can see, though it is not very clear, but I'll explain to you. This is a drawing of a sway frame where it is a showing correct elevation, top view. Then you have a small part details. Then you have sections. Here is a summary of the main material, which is directly linked to our advanced bill of material. You have a bill of material here with the total tonnage. So benefit that here is that they provide, when drawings are extracted from the Tekla model, they provide precise details needed to fabricate components that fit together seamlessly on site. So with precise and well documented instructions, the likelihood of errors in fabrication and assembly is greatly reduced. So you can understand 3D model, then output advanced bill of material, and then fabrication drawings. This is another fabrication drawing view. You can see this is a radial truss which we discussed in our earlier 3D model uh, on a complex model. These are the zoom views, everything shown clearly here, total bill of material. So you can just see the benefit, accurate dimension, material sizes, and that too, drawing automatically reflects the changes made in the model. That is very, that is the main advantage. You don't have to look into old drawings and see where are the changes, whereas we get it done automatically within the model. Similarly here, I can show you this is a typical erection plan of the same model which I shared with you, complex dome structure. Here, this is a top chord plan. This is a bottom chord plan. Then again, sway truss section. Then you have a radial beam typical sections. Then you have number of joints where these has to be field welded. So advantage you can see, you can see it shows how structural elements should be placed, assembled, and connected on site. Those who are not familiar with erection drawings, so that's why I want to show it here. That it shows how structural elements should be placed, assembled, and connected on site. Now, the benefit of erection drawing from 3D model is that all assembly marks shown in erection drawings are linked with the model and fabrication drawing. It means if I am making any change in the model, my advanced bill of material will get updated, my fabrication drawing and the small parts and even erection drawings, gets updated. So any changes made in the model gets updated in erection drawings as well. So these are the advantage I want to highlight here, which is a real advantage. And this is the erection drawing which is normally used by the erector at site. Then we have a consolidated quantity sheet. You can see here that for our some of the customers, they want all the quantity sheets showing bill of material, in a Excel form. So we have a standard kind of a consolidated quantity sheet. The real benefit is that it contains material quantity of a whole project required against each fabrication drawing. So it helps the procurement team determine exactly what materials are needed with what quantities, ensuring that the orders are placed well in advance. So, whenever we are sharing uploading the drawings to the customer, along with that, we also share this quantity sheet, which has every assembly drawing wise, which has a quantity, and this can be easily tracked. Another output file is a CNC file. This is, partly being used in India, but in US, this is the, at the when your drawings gets approved and ready for fabrication. At that time, our US customer asks for these files. These files can be fed into their CNC machine directly, and whatever shown in the Tegla model and approved drawings, they start the fabrication process. So CNC file normally provide the instruction necessary for automating and precisely controlling CNC machines during the manufacturing process. And benefits are this is created directly from the model without any user intervention. So these files enhance efficiency, precision, and reliability while reducing human error and production. So another such kind files is a DXF file, which is normally used for plate fabrication. Again, in India it is being partially used, but across overseas, including US, Canada, it is widely used, and this is a normal way of doing output files generated from 3D softwares like Tekla and other softwares. So DXF file, this file, those who do not know much about it, I want to explain. DXF file contains the geometrical shapes, elements that make up the drawing, such as lines, polylines, circles, arcs, and splines. DXF files are commonly used in CNC machine, laser cutting, and plasma cutting. Now, the benefits here are DXF files are created again, like other reports, are created directly from the model without any user intervention. And they can be easily recreated if the changes are made in the model. So you can see here whole chain right from the anchor advanced bill of material till the CNC file. Everything is well connected within the model. So there is no user intervention, and everything is getting coordinated automatically. So another requirement for our customer is a board list, which is again created directly from the software. And information what we provide in the board list is a board list typically contains essential data about each board, which is crucial for construction, fabrication, and assembly processes. Now the benefits of it directly from the model is generating the board list from 3D model ensures that the data is accurate and directly linked to design. So this reduces human errors that might occur when manually creating boards. It's looks very simple here when we are counting bolts manually. It's a very big task. You have to involve a separate guy for this. So if these things, if being taken directly within the model, is a real advantage, and accuracy is there. Similarly, this material management reports, these are other additional reports which some of the our US customer utilizes, but it is my duty to explain to you and show you that these are the reports. If required to you people, we can also provide these. These directly comes from the software. So number one is called MIS list. MIS means MIS list improves procurement and inventory management. Then you have another list, Power Fab report. It is streamlines steel fabrication and quality control. Then you have EJE report. EJE report provides real-time tracking and facilitates engineering job execution. So these are the outputs which I have shared with you, and you can see a real advantage there. So I would like to summarize this. You saw today we covered the evolution of traditional flow of drawings and information, how new tools like 3D modeling, BIM, and advanced material management can help streamline your process. Definitely improve project efficiency and reduce errors. So we also looked at real world examples how these technologies can be applied in your projects.